Then we have, now we talk about G, E, and C. G times E times C. Then we had adding in this, so this one we are subtracting this thing. So we have also this one, H, F, and A. H times F times A. Then we are talking, we had this one, I, D, and B. I times D times P. So this one is going to give us the answer. So we can take an example using numbers. Let us assume we have 1, 4, 3, 4, 5, 3, negative 2, 4, 3. I'm using a negative because normally say teachers use the simple examples, then they give the hard ones. So in that case, we take the two columns, we are going to add 1 here, 4 and negative 2. Then we have 4, 5, 4. So for the first case, what we do, we take these elements. So what we do with them, we're going to have 1 multiply 5 multiply 3. Because we are looking for the determinant, then we had 4 multiply 3 multiply negative 2. Then we have plus 3 multiply 4 multiply 4. Then what we are subtracting are now these. For the first case, we are talking about this one, and this one. Then for the second case, we will have that. For the third case, we will be talking about that. So we will be talking about, here now we are subtracting negative 2 times 5 times 3 plus 4 times 3 times 1 plus 3 times 4 times 4. So how do we go about it? 1 times 5 times 3, that is a 15. Then we are adding 4 times 3 times negative 2. This is 12 minus times minus 2, that's negative 24. Then we are adding 3 times 4 times 4, this is 16, this is 48. So in that case, for our first case, we have negative 24 plus 48 is 24. 24 plus 15, that is 39. So we are subtracting the second case. We have negative 2 times 5 times 3, that is negative 30. Plus, we have 4 times 3 times 1, that is 12. Then we have 3 times 4 times 4, that is plus 48. So in that case, negative 30 minus 48 is 18. 18 plus 12 is 30. So we are subtracting 30 and our determinant is going to be 9. So that is the simple case about how we go about the determinants. So then we can talk about application of matrix. So the first thing we talk about application of matrix is solving simultaneous equations. We can take an example. Let us talk about this easy example. 2x1 minus 3x2 equals to maybe 4. And then we are talking about 5x1 plus 3x2 equals to negative 2. So the simple thing we normally do when we have such kind of matrix, because we know from now we apply the principle of multiplication of matrix. Here we are going to form matrix. We are going to have 2. We pick the coefficients. Then we have negative 3, then 5, and then we have the 3. Then we are going to have x1 and x2 here. Then we are going to have the resultant for negative 2. In advanced mathematics, what we call this matrix, we call it A, and this one is normally called D. So in your books, you are going to meet an A and D matrix. This is what they are developed from. And when you look at this thing, let me show you something. Let me use another pen. So when we have 2, negative 3, 5, and 3, and then we are talking about x1 and x2, in simple terms, what we mean that we can take 2 times x1, 2x1 now, then minus 3x2. So we have almost the same equation we had here. Then we take 5x1, then we have plus 3x2. So this is almost the same equation we had here. So then we are resultant is 4. and here we are talking about -2. So this matrix, we can solve it. Let's proceed and solve that kind of matrix. So we are talking about a 2, a -3, and we have a 5, a 3, x1, x2, and here we are talking about, they are giving us 4, -2, and this is our matrix A, and this is our matrix B. So to solve this, what we normally do, we have two methods of solving simultaneous equation. One, we have the Cramer's rule, and also we talk about the inversion rule. So in most cases, we request students to use the inversion rule. However, we can solve it for 2 by 2. Let us solve using the Cramer rule. Then for the 3 by 3 matrix, I solve using the inversion rule. So for the Cramer rule, what we normally do, here we are talking about, you want to solve for x1. So when you solve for x1, you realize that these were the coefficients of x1. So what we normally do, we replace the coefficient of x1 with the D matrix. So in this case, instead of having a 2 and 5, and we are solving for x1, we are going to have these coefficients, 4, -2 in this place. Then we are going to maintain the other one, -3 and 3. Then we are going to divide with the A matrix. The A matrix of ours was 2, 5, then -3, 3. So in simple terms, you just replace, because these were the coefficients of x1, you replace with the D. And if you are solving for x2, you replace for the coefficients of x2, then you divide with the A matrix. So in this case, what you do, you find the determinant of this matrix. The determinant is found by the principal matrix, you subtract the other. So it's going to be 4 times 3. Then we are subtracting -3 times -2. In this case, we are going to have a 12, and then we are subtracting, these are negative and a negative, these are 6, it gives us a 6. So the determinant for this also, we do the same. It's going to be giving us 2 times 3, and then we are subtracting what? We are subtracting 5 times -3. Here we have a 6, remember, and then here we have 6 minus 5 times -3, that is -15, which is going to be 21. So we are going to have an answer 6/21 as x1. You can simplify it further to get, we divide by 3, it gives us a 2, it gives us 7. So x1 is 2/7. So for x2 here, for x2, now we take the same, so we have 2, 5, -3, 3, x1, x2, then we have our D matrix 4, -2. In this case, what we do, we replace now the coefficients of x2. So we are going to have, it's going to be x2, it's going to be given by, now we have the 2, 5, we remain with them, but for the x2 coefficients, we replace with 4 and -2. Then we divide by this matrix again. We have 2, 5, 2, -3, 5, and 3. And also we go by the way of finding the determinant. This is the principal diagonal. This is -2 times 2, which is -4. Then we are subtracting 5 times 4, which is 20, which is going to be -24. Then we are dividing by this one, we got 6, and this one we are subtracting. So we are adding 15, which is 21. So we have -24/21. And in this case, you can use divide by 3, it gives us an 8, it gives us a 7. It's going to be 8/7, but it has the negative sign. So x1 is 2/7, and x2 is -8/7. So that is using the Cramer's rule. So let us talk about the inversion rule. Talk about the inversion rule. So for this, let us use a 3 by 3 matrix, but we are going to use simultaneous equation. In most books, you are going to find it given input, output method. It is the same thing. So this is the same thing. So when you have a matrix, let us assume we have equations such as 3x1 plus 3x2 plus 4x3 equals maybe 2. Let us use 8. Then we talk about 4x1 minus 2x2. Let us say it is given as 7. And then we are talking about another type. We are talking about, in this case, let us not have x1. We talk about you have 3x2, then we have plus x3 is maybe negative 3. So when we have such kind of matrix, the first thing you do, you know that you have 3 elements, x1, x2, and x3. So when you form the matrix, you have 3, 3, 4 from this. Then for this, we have x1, which is 4, x2, which is negative 2, but we don't have x3, we equate with plus 0. Here we have x2, we don't have x1, so x1 is going to be a 0, x2 will be a 3, and x3 is going to be having a 1. Then we are going to have x1, x2, x3. So these are A matrix. So our D matrix is going to be 8, 7, negative 3. So to solve this, to solve for x1, x2, x3, the answer is always found by A inverse. In now this case, then we are going to multiply the D matrix. So this is the answer. So how do we get to this A inverse? The first thing we do, we have steps. Then the first step, we find what we call the minus. So the minor, what we normally do when we are finding a minor, let us find the minor for 3. For 3, the minor, we stand at 3. When you stand at this 3, we are going to assume we don't see what we normally assume. When you are looking for the minor for 3, you don't see this, as well as you don't see this. So for the minor for 3, we are going to have negative 2, 0, 3, 1. Then you find the determinant for this, which is going to be negative 2 times 1, that is negative 2. Then you are subtracting 3 times that is a 0, so it is going to be negative 2. Then you come again, you stand at this point. We are talking about the minor for 3. So 3 is here. So what you don't see these elements and these ones. So you cross this element. For the minor for here, we are talking about the minor for 3. We are going to have 4, 0, 0, and 1. And in this case, when you multiply them, this is 4 times 1. It's going to be 4. These are 0 minus 0 is going to give us a 4. Then you come here, you are at 4 now, the minor for 4. When you stand at 4, you don't see this column and you don't see this. So you are going to have 4, negative 2, 0, and 3. And in this case, we have 4 times 3, which is 12. Then this is going to be a 0 minus 0, which is going to be 12. You come to the second row, you are looking for the minor for 4 again, but now we are talking about this 4. When you talk about this 4, we say you don't see this column, and also you don't see these 2. So you will be having a 3, a 4, a 3, and a 1. So in this case, we'll be having 3 times 1, which is 3. Then you are subtracting 3 times 4, which is going to be 12, which gives us a negative 9. Then you come here, you have a minor for negative 2. When you're talking about negative 2, you don't see the entire column, the entire row, and the entire column. So we are going to cross this way, and then we cross the 2. Then we are going to have 3, 0, then 4, 1. 4, 1. So in that case, we are going to have 3 times, this is 3, this is going to be 0. So we have it as 3. We can continue, and now we come at the minor for 0. Looking for the minor for 0, we are at this point, we cross this point, and we cross this point. So we are going to have 3, 3, 0, 3. So when we multiply, this is 9 minus 0, which is going to give us a 9. Now we come for the minor for this 0 now. So when you stand here, you cross this and you cross the 2, then you are going to have 3, 4, negative 2, 0. And in that case, we are going to have 3 times 0, which is 0. Then we are subtracting negative 2 and 4, that is negative 8. So it is going to be 8. Then we are standing at this 3 now, the minor for 3. When you talk about the minor for 3 here now, we are talking about this 3. What you do, you stand at this point. So we are going to cross this one as well as we cross these 2. So it's going to give us 3, 4, 4, 0. So when we multiply, this is going to be a 0, then we are subtracting 4 times this. This is 16, it gives us negative 16. Then we are talking again about now this 1, the minor for 1, you cross this, and you cross this. So we have 3, 3, 4, negative 2. So in this case, we are going to have 3 times negative 2, which is negative 6. Then we are subtracting 4 times this, which is 12. So negative 6 minus negative 12 is negative 18. So we have our matrix now, our new matrix. Our new matrix, we are talking about negative 2, 4, 12, negative 9, 3, 9, 8, negative 16, negative 18. So this is our new matrix. So let us start this matrix this way. So the next thing, after having the minus, let us find the determinant of our A matrix. Not our new matrix, our A matrix. So we are talking about the 3, 3, 4, 4, negative 2, 0, 0, 3, 1. So this is the matrix we are talking about. How do you go about it? We had the columns. We are going to have 3, 4, 0, 3, negative 2, 3. So we have that, we have that, we have that. So what we do, 3 times negative 2 times 1 plus 3 times 0 times 0 plus 4 times 4 times 3. In this case, we are talking about 3 times negative 2 times this is going to give us negative 6. This is going to be a 0 because of the zeros. This is going to give us 48. So it's going to give us something like 42. So what we are subtracting from that case, we are subtracting this, this, and that. So we will be having 0 times negative 2 times 4. We are supposed to add, in that case, 3 times 0 times 3. Then we are also adding 1 times 4 times 3. Thank God we have a 0, this is a 0. We had this a 0. Then we are adding a 12. It's going to give us 12. So we have 12 and 42. So in that case, we're talking about our determinant is going to be 42 minus 12. So that one gives us our determinant equals to 30. So we have the determinant and we have our new matrix. So we continue from our new matrix. From our new matrix, here we are talking about our new matrix, negative 2, 4, 12, negative 9, 3, 9, 8, negative 16, negative 18. We have what we refer to as cofactor. That's our second step. When we talk about the cofactor, a matrix is always defined by the following cofactor: positive, negative, positive, negative, positive, negative, positive, negative, positive. So always a matrix is always defined in that format. We start with a positive, a negative, a positive, a negative, a positive. So when you talk about the cofactor of this matrix, we have a positive. A positive times this negative is going to give us negative 2. So we are finding the cofactor for our new matrix. Then we have a 4 times a negative, it's going to be negative 4 in that case. Then we have a 12 times a positive, it's going to remain a 12. Then we have negative 9 times negative, it's going to be 9. Negative times negative is a positive. Then we have a positive times 3, it's going to give us a 3. Then we have 9 times a negative, it's going to have as negative 9. We have 8 and a positive, it's going to be 8. We have negative 16 and a negative, it's going to be 16, a positive. And we have negative 18 and a positive, it's going to be a negative. Negative multiply a positive. So that's what we refer to as the cofactor of our new matrix. We only look at the signs and try to interchange the signs for the cofactor. Then our step number 3 is finding the transpose of our matrix. And when we talk about the transpose, we talk about the rows become what we call the columns. And in this case, this is our row. It now becomes a column. It becomes negative 2, negative 4, and 12. This, our second row, becomes a column, 9, 3, negative 9. This one becomes also a column, 8, 16, negative 8. So that's what we refer to as the transpose of these matrix. So the fourth step is now inversing the matrix. We inverse the matrix because it was the inversion rule, so we inverse the matrix. So the inverse of A matrix is A inverse. So what we normally do, the inverse of this matrix, is we are going to use what we refer to as, want to inverse this matrix. What we do, we divide the matrix with our determinant. It's going to be, the inverse is going to be given by 1 over determinant, then the transpose. This transpose matrix we have is going to be given as that way. So how do we go about that? So let us continue. Let us join arms, and so we are trying to inverse this our matrix. Our determinant was 30, so we have 1 over 30, and then our matrix here we have negative 2, 9, 8. Talking about negative 2, 9, 8, we have negative 4, 3, 16. Then we are talking about 12, negative 9, negative 18. So this is our matrix that we are trying to inverse. So to inverse that matrix, we are going to have negative 2 over 30, 9 over 30, 8 over 30, negative 4 over 30, 3 over 30, 16 over 30, 12 over 30, negative 9 over 30, negative 18 over 30. So this matrix can be written in simpler terms. We can have, for the first case, it's be negative 1 over 15, 2 divided by that. Then this one we divide by 3, or in 3. So it's going to be giving us 3 over 10. This one we divide by 2, it's going to give us 4 over 15. We divide by 2, it's going to give us negative 2 over 15. We divide by 3, it's going to be 1 over 10. This one we divide by 2, it gives us 8 over 15. This one we divide by 3, it gives us 4 over 10. This one we divide by 3, it gives us 3 over 10 negative. This one we divide by 6, it gives us negative 3 over 10. So this is our matrix, our inverse of the matrix. But we were not looking